very grateful for being a part of this exercise, and for me especially, it's great to be back here in Isfjorden, because this actually used to be my playground during my master thesis. And I was driving up and down the glacier behind us there, Kroneveden, Holtafonna, Kongsvegen. I was putting out a lot of GPS or GNSS equipment, and I had a great time. So it's very nice to be back. So for this presentation, we will focus on satellite-based search and rescue technology. And in some of the previous lectures, I believe yesterday and the day before, the focus was mostly on being proactive and the behavior for avoiding accidents. But today we are going to talk about the equipment you're going to use, or that you can use, if you're actually in distress and you want to ask for help. So yeah, again, my name is Kenneth Bahr, and I'm from the Norwegian Space Agency.
Hello everyone. Yeah, I'm Novell. Also very grateful to be here. I was in Svalbard last year. I thought it was once in a lifetime for the AMRO, and now we are back here, so super excited as well. So yeah, indeed, as Kenneth said, we are gonna give you an overview on satellite-based technologies that help in the search part. So we saw that the previous presentations as well. So I guess we crack on and let's start. I guess we can. That's what we're gonna try to speak about. Why are we here? How the satellite technologies can help us in distress situations, and what is our role in this exercise that we are gonna do tomorrow.
Yeah, that's a nice picture of Paul from last year's exercise. Ready to be evacuated by the helicopter.
So that's a thumbs up. Everything's good. Hoist me up.
And also, we have a little bonus at the end, because we will actually do a demonstration of the equipment. More on that later. Yeah. So just briefly, what organizations are we representing? So I come from the Norwegian Space Agency, and we are a government agency under the Ministry of Trade, Industry and Fisheries. And in short, we are responsible for organizing, promoting Norwegian space activities, especially with the EU and ESA, and also the national space activities.
All right. So I come from the EU Space Program Agency, or EUSPA. It's a quite young organization. It was previously called GSA, and we have the mandate to operate, exploit the Galileo, EGNOS, Copernicus, and upcoming other space programs funded by the EU. So that's our organizations. Let's move on.
And I can also mention that the Norwegian Space Agency became a member of ARCSAR just a few months ago. And I guess that's too late, because this is a really interesting project, and kind of the main goals for the project, they overlap with some of the major goals also for the national space activities, and also for the space agency's goals as well. So we find it very useful to finally become a member of the project, but it's almost too late. Okay, so I just, on the left side here, I borrowed a figure from the JRCC, and it shows the area of responsibility for the Norwegian rescue services. And also to the right, you see within the blue, the red lines, you can see the Norwegian maritime borders. And why am I showing you these two figures? Well, it might be obvious to all of you, but these are actually vast, huge areas. And sometimes these map projections can fool you into thinking that, well, these distances aren't that large, but they actually are. And just to help you to realize how big they are, this figure to the right has overlaid the boundaries of some well-known European countries, France, Spain, Portugal, UK, and Germany. So then you know, or you get a better feeling of how big these areas are. And of course, we are relying on infrastructure to be able to communicate, to position ourselves and to position others, and for this case, also for search and rescue. And for these large areas, you cannot only depend on ground infrastructure for all these applications. You need space infrastructure. Yeah. Yes.
Yeah, I guess this is a little taste on what's gonna come afterwards. But as I mentioned before, last year we tagged along as well into SAR exercise, and we were lucky enough to demonstrate and be here and be able to perform this test where we actually prove that these space technologies are like really tangible and it can really improve and save your life. So you have here like the overall results that we obtain, and they are quite astonishing. I mean, the response time that you get from a satellite system up to the rescuers, especially in places like this where cold water is going to eat your life away. It was really good. I guess we will be talking about it in the next slides, but just a little taste. You gonna go do one or? Yeah, I think we mainly express why are we here, but essentially at least from my side, we are providing services to users, and our users are mainly the SAR forces in this case for the SAR Galileo, and essentially we need to understand the needs in order to for the service to be useful. We are here to draw lessons learned, to understand more of the operational side of things, what's useful, what's not, how can the service be evolved. Also to share and promote the services being provided, and I believe it's still some of these technologies for you guys, it's probably a daily use, but for most of the people are still unknown. What's a beacon, what's COSPAS SARSAT, what's 406. So yeah, essentially promote do some outreach. So you want to add something?
I'll cover it up,
Yeah. So I guess that's not the best important thing. So let's move to the next one. So in the upcoming slides, I'm going to talk to you a little bit about the Galileo Search and Rescue Service, and also about this international network called COSPAS SARSAT. I believe some of you, or maybe all of you, know it, but just a little overview and a brief, so we know what's going to come. Yeah. Quickly, a background slide. This is quite interesting. The COSPAS SARSAT organization was founded in the 80s, early 80s. Interestingly enough, during the Cold War, and you can see up there, it was the first treaty was signed by USA, USSR at that time, so Russia, Canada, and France. And it has grown up to now to be really an international organization with more than 43 participants and lots of ground and space segment providers. So you have here a few pictures of the first satellite rescue, and then the MOU signature. And I like also to put this slide first as well. Those are quick facts from the reports on last year, and you can see really why this service is quite unique. So thanks to these little beacons, around what's the number? Yeah, around 3,630 people were actually rescued and they saved their lives. So it is something not to be disregarded. So you have here the distribution on the Earth, and also per type of beacon, or segment. So we have the maritime, the land-based, and the aviation users. Well, yeah, also a point to be highlighted for you guys, I guess, for the GRCC people and SAR Coast Guards. The false alert rate, it's quite high. It's 96.1% of the transmissions are estimated to be false alerts. So either mishandling, sorry, oops, I activated without willing, no, I was doing a test, or simply I activated and I was not in distress. So yeah, it's something that I guess the operational people is able to cope, because as we saw at the beginning, the system is running for a long time now. So, but it's a quite interesting fact that 96% of the transmissions captured are not considered distresses. Yeah, so this is a little bit of an overview on the Galileo services being provided and how the search and rescue falls within the portfolio. We have we separated into what we call the forwarding service, which is the classic location of a return of people or someone in distress, activating these elements, and what we call the return link, which will come afterwards. It's a new service being offered as of 2020, which provides confirmation to the people activating the beacons that the system has worked well. And yeah, there's upcoming new services based on that, such as the Galileo emergency warning service, but that's for another talk. I guess up to now you're more or less aware of how the CONOPS of the search and rescue and the Galileo COSPAS SARSAT would work, but essentially everything triggers from a user being in distress. So guys, please, this is important. You don't trigger these beacons if you have a flat tire or if you have cell phone coverage. It's really when it's the last resort, you're alone, you are in a distress, you activate the beacon, signaling that you are really on a distress situation. So those beacons emit in a 406 band. These transmissions are collected by the space infrastructure above us. So in particular, we can speak about the NEO satellites, the NSS satellites, Galileo, GPS, and GLONASS, essentially, which rely these transmissions back to a network of ground segments that automatically and independently calculate the position of your distress, and this position is sent to the associated or the relevant coordination forces of the location where you are. So if you are in Norway, it will follow to the GRCCs. If you are in Spain, it will be the Spanish MCC, which will coordinate the associated search and rescue force. So that's how the concept of operations works. Next slide. How Galileo contributes to this system. So it does it in three ways. Essentially, providing SAR payloads on board of the constellation. So there are currently 24 spacecrafts flying with SAR capabilities. We provide also a ground segment associated to it. So we have 3 stations deployed in Europe, a 4th coming in the Indian Ocean. And we also are providing this, what we call the return link. So a quick fact as well, you have it on the screen. So it's one of the largest space segment provider, ground segment provider, and this is the SAR Galileo. It's being operated with 1% of the overall Galileo budget. So I think it's a very good investment of money. Following slides, just a couple of pictures on the left. The first Galileo payloads being launched in 2012, and close-up link, a close-up photo from the satellite where you can see the different payloads and how it works with the SAR. So on the bottom we have the search and rescue transponder that picks up the signals and relay them to the ground. Those are the 3 stations that we have in Europe. So we have one in Longyearbyen, in the CASAT facilities. We have one in Maspalomas, in the Canary Islands, and we have another one in Cyprus, in Larnaca. So these 3 give us the coverage for at least a very good amount of European zone. And now the return link. So when you're out and about, you are in a distress situation, you're in the middle of the sea, you activate your beacon, you're happy that you have it, but you don't know if that beacon is transmitting, you don't know if this is something working or not. So we designed, and in cooperation with COSPAS SARSAT, this what we call the return link service, and this is how it works more or less. So you are in distress, you activate your beacon, so it transmits. Along with the transmission, there is a return link request that is transmitted as well. So yeah, just move on. So this transmission is picked up by the satellites, which is then relayed into the ground by the ground segments. And then this transmission request arrives to the COSPAS SARSAT mission control centers, which confirm that they have located you. And then once this is confirmed, this is routed through the different operational networks up to the Galileo infrastructure, what we call the Return Link Service Provider, or RLSP. So this is the infrastructure in charge of connecting the external entity as COSPAS SARSAT to the Galileo system, which then uplinks a message back to the Galileo constellation, and it is broadcasted back to the beacon, saying, "Hey, we hear you. We have got your request. This has been acknowledged by the COSPAS system. We know you are in distress. We have located you. So stay calm, stay there, stay put." It doesn't mean that the SAR forces are already on their way. It just means that the system knows that it has worked and you have been located. So that's a relief, I believe, for most of the people which will be in distress in the sea. So yeah, that's an innovative system and a service that was introduced in 2020, and it takes an average time of 37 seconds from the Galileo infrastructure back to the beacon, but in an overall end-to-end latency below 5 minutes. So I believe that's very well. I think last slide here you can see a little bit of the coverage area that we are monitoring constantly, and a few performance parameters on the service that we constantly monitor and publish, by the way. So if you're interested, there are quarterly reports on that. So draw your attention to the graph below, and that's a mean location error on the beacons that are transmitting within this area, and it's around 800, 900 meters, an independent location. So it's not really based on the GNSS position that these beacons transmit, but the independent position that is calculated by the system. So I think that's pretty reasonable position for SAR forces to locate you. And then I hand it to you for the next part.
Yeah, thank you. So Paul has been talking about these COSPAS SARSAT compatible devices, and I will also briefly talk about these AIS compatible devices, because I guess most of you know a lot about AIS, because it was originally supposed to be a collision avoidance system, and it's grown into also this kind of large ship monitoring system as well. As you see here on the right side, we can see the recorded AIS position for this Arctic area. So the AIS systems, for those of you who don't know, is that basically the ship would then report its identity, its position, its velocity, where it's heading, etc. And this it would transmit to ships nearby or to ground infrastructure that would be able to pick up the signal. But also now it is possible to send this data to AIS or satellites with AIS receivers on board. And in Norway we have a national capacity for satellites with AIS receivers on board. We have AISat 1 and 2, in addition to NordSat 1, 2, and 3. This is a picture of the number 3, which was launched last year. Which we will come to in the next session. For the test during the exercise, we would like to see if this AIS SARTs and also the AIS man overboard units, if it's possible to detect these signals, which are a bit weaker than the AIS signal that the ship here is transmitting, if those signals are detectable from the AIS satellites. Yes, so I guess that brings us to the last part. What are we going to do now during this exercise? Well, we started already, I believe, 1 hour after embarking the ship, because we mounted a COSPAS SARSAT compatible PLB in the front of the ship. I believe most of you have already seen it, co-located with the Garmin GPS. And that's part of the part 2. So this overview is it's quite extensive. So I will I'll try to briefly explain what we're going to do. So we will evaluate the performance of multiple COSPAS SARSAT and AIS beacons in different environments. So for instance, here we are evaluating the performance of the COSPAS SARSAT on a moving ship at different velocities. Our colleague Knut Espen Solberg, also from the Space Agency, is currently on board the Coast Guard ship Barentshav, and he is performing the same type of tests, controlled tests of these different beacons and they are mounted high up on the Barentshav ship. And then, in addition, they also they made 10 different clusters of dummies and of different constellations of these type of equipment. And they dumped it into the ocean. Well, they activated the units and then they dumped it into the ocean. And they have now been floating for quite a few hours. And the SAR Queen, the helicopter from the 330 Squadron, I believe it's already on board the Coast Guard ship. They're supposed to do an exercise where they will try to find each and every cluster that is floating into the ocean, and by then using the different localization techniques. They will search with the homing frequency 121.5. They will try to get the AS positions and also go after the COSPAS SARSAT registered position as well. So it's going to be interesting to see if they can find all these dummies and all these clusters. And then we have the full-scale exercise, which is tomorrow. And then it will start by the initiation of exercise, where we will activate, I guess, 1 or 2 EPIRBs that will kind of initiate the entire exercise. And also we will have several units that will be used during the evacuation phase tomorrow. And then, meanwhile, during all these tests, we will have a ground truth with different, like, separate GPS units, so we can kind of also evaluate the positioning performance. Yeah. Do you have something to add for the tests?
No, I think that's about it. Yeah.
Yeah.